is going to be recorded. There we have it. We are inviting Katy Wolf to speak about safer alternatives, reducing VOCs and HAPs in the metal finishing and aerospace industry. And I believe you're introducing yourself, or Donovan, were you? Oops. Okay, can someone promote Donovan to introduce Katy? Thank you.
So excellent. I'd like to introduce Dr. Katy Wolf. She has been working with the executive director for the Institute of Research and Technical Assistance in Los Angeles, working with a lot of different safer alternatives for various solvents, established and operated the Pollution Prevention Center there, and conducts a lot of technical pollution prevention and green chemistry projects, which is why we asked her here today to talk with us on the subject. It's a little bit different than what was listed as it will touch on metal finishing, but is more on the safer alternatives to solvents. I can't find where she sent me the update, but Dr. Wolf, it's all yours now.
Can you see my screen?
We don't see it yet. And are you going to be on camera with us?
No, I'm sorry.
Okay. All right.
I'm pushing share screen and it's not doing it for some reason.
Well, we'll check on our side to see if there's something we need to do.
Right. And so you might want to stop sharing. And hi, Katy, it's Nancy Larson.
Hi, Nancy.
And so you might want to just stop sharing for a second. And then when you go to reshare, pick this. If you've got multiple screens, you want to pick the screen that has your presentation on it.
I've already been doing that. And I see the green share screen button. I've pushed it. And then I click on my screen, the screen that I want to show, and it's not doing it.
Sure. And then so when you click on the screen you want to show, you then say, yeah, that you're sharing, you move down below. So you click on that screen you want to share, and then you move down below to say share. So it's actually asked you to kind of confirm it a couple of times. That could be it.
It's not doing it. I'm very sorry. I don't know.
Oh, that's okay. Would you like to email it to me and I will get it?
Now let me just get it in presentation.
Oh, there we go.
There comes up.
Okay.
There we are.
Yes.
Sorry. Apparently I'm technically challenged. So hi everybody. I'm going to talk to you today about safer alternatives to vapor degreasing. Now, vapor degreasing is a process that's used by numerous companies across the country for cleaning their parts. And the dominant industries that rely on vapor degreasing are metal parts manufacturers, finishers, and assemblers, as well as nearly all aerospace manufacturing. And in addition, several electronics manufacturers and assemblers also use vapor degreasing. Now, in 2016, Congress amended the Toxic Substances Control Act. And under those amendments, EPA was charged with developing a list of chemicals that they believe posed a high risk. And they've developed the list of the first 10 priority chemicals. And on that list are 4 solvents that are extensively used in vapor degreasing. These include trichloroethylene, or TCE, perchloroethylene, or PERC, methylene chloride or MC, and N-propylbromide or NPB. And all 4 of these solvents are carcinogens, and they pose other health and environmental effects as well. And all of them are on EPA's hazardous air pollutants list. Now, how does vapor degreasing work? Well, I'm just showing a simple schematic here, and a vapor degreaser is a stainless steel tank with a heater in the bottom and a set of cooling coils around the top. You put liquid solvent into the vapor degreaser and you heat it to its boiling point. That creates a vapor zone above the liquid zone. Those vapors would tend to escape from the vapor degreaser were it not for the cooling coils around the top, which hold those solvent vapors in them and keep them condensed. Now you load parts into the vapor degreaser, most often in a basket, but sometimes also on fixtures of various kinds. And when the solvents go into the vapor zone, they encounter the warm solvent vapors there. And those vapors condense on the colder parts and they carry the contaminants on them down into the liquid below. And if you always clean in the vapor zone, you'll always be cleaning with clean solvent. Most degreasers are actually more complex than the simple view that I've given you right there. And almost all vapor degreasers have a spray wand that can be used to spray liquid solvent on the parts in the vapor zone. And in other cases, vapor degreasers will have baths of solvent with agitation of various kinds, and you can immerse the parts in them for better cleaning. Now, this last point is very important, and I want to emphasize it. The solvents that are used in open-top vapor degreasers can't have a flash point. If you heat a solvent to its boiling point and it has a flash point, you'll reach the flash point first. And since we have oxygen present in an open-top degreaser, if we also have a source of ignition, we could ignite that solvent or blow it up. So that's very dangerous. We don't want to use solvents with flash points in vapor degreasers. Now I'm going to present a number of different case studies, and I'm working currently, I'm actually living in the Pacific Northwest, no longer in Southern California, and I'm working with 4 companies on a project that's sponsored by EPA Region 10. And I'm working with a nonprofit called the Pollution Prevention Resource Center. And all 4 of these companies are using N-propylbromide in a vapor degreaser. And I'm assisting these companies all in converting to safer alternatives. I'm working with 2 companies on a project sponsored by the Hazard Evaluation System and Information Service, which is part of the California Department of Public Health. And those 2 companies are also using N-propylbromide. Then historically, I ran a nonprofit in Southern California for 30 years, and I worked with a number of companies helping them to convert. And I'm going to present case studies on 2 of those. Now, before I talk about what the potential alternatives are, I just want to give a historical context to the vapor degreasing process. And right after World War II, a solvent that I already mentioned, trichloroethylene, started being used. And then somewhat later, PERC and methylene chloride started to be used. By the time we hit the mid-1990s, there were 2 ozone depleting solvents, which were also extensively used by industry. These included 1,1,1-trichloroethane or TCA and a chlorofluorocarbon called CFC-113. And in 1996, as some of you may know, the US joined the Montreal Protocol in banning ozone depleting substance production worldwide. And the thousands of companies that were using TCA and CFC-113 in vapor degreasing had to convert away. So the vendors saw an opportunity at that point, and they began introducing new products to the market. One such product was the hydrochlorofluorocarbons. They also contributed to ozone depletion, but somewhat less than the CFCs. So they were phased out over the next 15 years or so. N-propyl bromide was also introduced onto the market at that time. Then a little later, some global warming solvents, the hydrofluoroethers and hydrofluorocarbons, came onto the market. And also another chlorinated solvent called 1,2-trans-dichloroethylene. And over the last, I don't know, 35 years, there's been a lot of switching from one solvent to another in vapor degreasing as the solvent that companies are using becomes increasingly regulated. So what are the potential alternatives to these 4 halogenated solvents used in vapor degreasing? Well, one alternative is the fluorinated solvents, which I already mentioned, the hydrofluoroethers or hydrofluorocarbons. Now, the problem with these solvents is they do contribute to global warming, so they could ultimately be regulated for that reason. In addition, they don't clean very effectively, so virtually always they're combined with another solvent I mentioned, the 1,2-trans-dichloroethylene, to boost their cleaning capability. Now, 1,2-trans has not been tested for chronic toxicity, but it is structurally similar to TCE, PERC, and vinyl chloride, and those are all carcinogens. So 1,2-trans could ultimately be regulated for that reason. The HFEs and HFCs are also extremely expensive, so they're almost never used in open top vapor degreasers where their emissions would be so high that the replacement costs would be onerous. So they're almost always used in airless airtight equipment. These would be things like vacuum degreasers, and those systems turn out to be very expensive. The smallest kind of vacuum degreaser you could ever buy would run you around $100,000, and most would be in the range of $400,000 to $1 million. Another fluorinated solvent is a hydrofluoroolefin. Now, it does not contribute to global warming, but a toxicologist in California has evaluated its toxicity and she believes it to be cardiotoxic. It's used in open top systems, but those systems are very expensive, as is the HFO. Another potential alternative is to use solvents with flash points in vapor degreasing. And I've just listed several there. 1,2-trans is a solvent with a flash point. There are lots of oxygenated solvents like glycol ethers and modified alcohols, which have flash points, and hydrocarbon solvents, of course. These solvents can't be used in open top vapor degreasers, as I already mentioned, because of the presence of oxygen and the threat of a fire or explosion. So they have to be used in airless airtight systems. And again, that equipment is expensive. And some of the solvents could be toxic. I already mentioned the problem with 1,2-trans-dichloroethylene. Certain glycol ethers have toxicity problems, and hydrocarbon solvents often contain aromatic components. Those would be things like benzene, toluene, and xylene, which are very toxic. Another potential option is to use solvents with flash points in a cold cleaning operation, that is where you wouldn't heat them. And I've added a couple solvents to the list here. One is parachlorobenzotrifluoride, or PCBTF, and that turns out to be a carcinogen. Also, the volatile methyl siloxanes, one of those that is a solvent, D5, is also a carcinogen. And in addition, cold cleaning is not as effective as vapor degreasing in cleaning parts, so most people doing vapor degreasing might not find it an adequate process. Then I've separated out soy-based cleaners, and these are good for cleaning in certain applications. Companies who make optical components generally polish those components with materials like pitch and wax. And those are extremely difficult to remove, and soy-based cleaners can do that very effectively. There are various other methods that can be used on a case-by-case basis. For example, some companies might be able to use a burn-off oven to decompose certain oils on their parts. Companies assembling printed circuit boards, they might be able to adopt a no clean flux, which means you wouldn't have to clean it off at all. And companies who are refurbishing heavily contaminated parts from the field and bringing them in, they might be able to use blasting media of various kinds to clean their parts. Now, the last option I'll mention is water-based cleaners, and I'm going to talk a lot more about those in what else I have to say. So taking into account the health and environmental effects that I've mentioned, some of the cost and technical feasibility issues, water-based cleaners are really the best option, and they're actually appropriate for almost all of the operations where vapor degreasing is used today. And as I also mentioned, soy-based cleaners and other safe methods might also be appropriate on a case-by-case basis. Now, in my Pacific Northwest project, all of the facilities I'm working with, the 4 facilities, are converting to water-based cleaners. In my California facility project, 1 facility is converting to a soy-based process and the other to a water-based. And in the earlier projects I worked on in the LA area, both of the facilities I worked with ended up converting to water-based cleaners. Now, the first case study I'm going to talk about is a company called MAPSCO. They're an aerospace subcontractor in the Seattle area, and they offer non-destructive testing services. The type of non-destructive testing they do is magnetic particle inspection. And the way that works is you have a fluid and it has magnetic particles in it. You put the parts you want to test into that fluid and you apply a magnetic field. If the part has a flaw or a crack in it, those magnetic particles will align up along the flaw or crack. You can identify where it is and you can fix the part instead of getting rid of it. So MAPSCO historically used a 130-gallon N-propylbromide degreaser for removing the oils from the parts when they came into the facility and also cleaning the non-destructive testing fluids afterward. We worked with a water cleaner supplier, and that supplier was already supplying MAPSCO with a water-based cleaner and other operations in their facility. And MAPSCO wanted to convert to that water-based cleaner throughout if they could. So we did the testing in the type of equipment the company would need, and it worked well. Then I sent in an equipment supplier who had the type of immersion agitation equipment the company needed. He gave them a quote, and MAPSCO believed it was too high. That equipment supplier also represented a lower cost equipment line, and MAPSCO also felt that that quote was too high. MAPSCO did find a secondhand system, but another company bought it first. So then I got in gear and I identified a company that had secondhand systems, and it turned out they had the exact type of system we had originally quoted for MAPSCO. MAPSCO ended up purchasing it, installing it. It's been there for almost a year now, and the system's working very well. Here's a picture of the non-destructive testing stand at MAPSCO. This is a picture of the 130-gallon vapor degreaser the company had. And this is a picture of the water cleaning system they ended up purchasing. And it has 3 baths. It has a wash bath, a rinse bath, and a forced air dry. And as you can see from the picture, it has an automated handling system that's used to index the baskets from one chamber to the next. Now, this slide shows an annualized cost comparison for MAPSCO for, on the one hand, using the vapor degreaser, and on the other hand, using the water-based cleaning system. Now, I'm presenting the cost in the form of an annualized cost because I think that's more inherently understandable. And I don't generally include a capital cost for the vapor degreaser. Most people have very old, horrible vapor degreasers, and they've been fully paid off and amortized, so I don't consider that. In contrast, I do consider the capital cost of the water cleaning system. In this case, the cost of the water system was $55,000. The company, MAPSCO, also decided to upgrade their electrical system to accommodate the use of the water cleaning system, and that cost amounted to $12,000. Since that was a one-time cost, I added it to the cost of the water cleaning system, and that totaled $67,000. I amortized that cost over a 10-year life for the equipment, even though most equipment of this kind will last 20 years or longer. To be conservative, I used a 10-year life, and I used a 3% discount rate. And you end up with a $7,000 annualized cost when you do that. Now, as you see, the cleaner cost in the case of the vapor degreaser is higher than the cleaner cost in the case of the water-based cleaner. That follows from the fact that water-based cleaners are generally sold in concentrate form, and they range in costs. They're about $19, $20 a gallon. Now, when you use that cleaner, that water cleaner, you're going to dilute it to 5 or 10% concentration in water. So you're really using very little. And in this case as well, since we have very good control of the oil and the filtration, MAPSCO doesn't have to change the water-based cleaner out more than twice a year. So that's why that cost is low. As I mentioned, we have filters in the system. That's $75 a year. Now, as you see, the energy cost for using the vapor degreaser is higher than the energy cost for using the water-based cleaner. You have to heat the N-propyl bromide to its boiling point of 160 degrees. In addition, the vapor degreaser had 2 sets of cooling coils around the top, and that took a great deal of chiller capacity to cool that down. So that's why that's higher. Now, as you see, the labor cost increased when MAPSCO went to the water cleaning system, and they've added another cleaning task to the system, and it's a set of parts that go through a MAPSCO operation. Now, I don't show a personal protective equipment cost for the vapor degreaser. If you remember from the picture, it was enclosed. Now, as you see from the figures, the disposal cost for the halogenated solvent is quite high. Halogenated solvents are expensive to dispose of because they have to be incinerated. Now, in this case, I don't show a cost for disposal of the spent water cleaner. It turns out that MAPSCO has a wastewater treatment system on site, and they treat a large volume of water through that system. And treating the 2 baths per year that they need to change out of the water cleaner just adds a slight incremental cost. So we deem that to be negligible. Now, as you see from the total cost of using the vapor degreaser is a lot higher than the total cost of using the water cleaning system. MAPSCO was able to reduce their cost of cleaning by some 27% by moving to the water-based cleaner. Now, another company I'm working with in my Pacific Northwest project manufactures small diameter tubing, 1/8 inch diameter and larger. And that tubing is used to transfer liquids and gases from one place to another in aircraft. Now, as you can see from the pictures of the tubes, some of them have multiple bends, and they're maybe 4 or 5 feet long in some cases. And the company uses a water-based lubricant in their bending operation. We worked with a water cleaner supplier and conducted testing, identified a water cleaner that worked well. And then I brought in an equipment supplier. Now, the equipment supplier and I knew of another company that had very similar operations in Southern California. And a few years before, that company had converted to an ultrasonic cleaning system using a water-based cleaner. Now, we knew that ultrasonic systems are quite expensive, so we wanted to see if we could do the testing in a spray cabinet with a specially designed fixture that would hold the tubes in place while we sprayed cleaner on the inside. We did that testing, and the parts after the testing were sent back to the company. They cut them apart and they said that they were clean. So we gave 2 quotes to the company, one for the spray cabinet and another for the ultrasonic cleaning system. And as expected, the cost of using the spray cabinet was less costly than the cost of using the ultrasonic system. Another company I'm working with in the Pacific Northwest project manufactures ducting for aerospace and industrial applications. And the company forms these ducts into various shapes, and they use forming lubricants that they then need to remove. And they've been using an N-propyl bromide degreaser to do that. They have a number of water cleaning systems in their facility, and they decided they wanted to convert them all to 1 or 2 at most. And so we're doing the testing on the parts that go through the vapor degreaser with 2 different water-based cleaners. And the company plans to ultimately use a cleaning system that they already have in place, an immersion agitation system. So we're not finished with that project yet. I'm also working with a plating company in that project, and they have to remove polishing compound from their parts. Polishing compound is very difficult to remove, so they are going to need an ultrasonic cleaning system, which is an aggressive cleaning system to do that. We tested some water-based cleaners with a cleaner supplier and found one that was suitable. And the company right now is evaluating what size of an ultrasonic system they want to purchase. Then I worked with a manufacturer of microelectronics in my California project, and their microelectronics go into medical devices. And those medical devices are regulated by the FDA. And they had to get permission from the FDA in order to convert to a water-based cleaner. And generally that's very hard to get. I prepared some information for the company, and they asked the FDA, and the FDA did approve a conversion to a water cleaner. Now, partway through that project, the company told me that they already had a water cleaning system. They were removing flux from printed circuit boards with a water-based flux remover in a dishwasher system. Now, that was not necessarily the water cleaner that I would select for cleaning the microelectronic components, but I thought if it worked, that would be great. So we did the testing, and the company did a lot of quality control and looking at the parts after the cleaning tests, and they were successful. So the company was able to just not purchase another system, and they're able to just move those parts that went through the vapor degreaser previously through that existing system. Now, as I already mentioned, I'm working with an optical components manufacturer in the California project, and they are removing pitch and wax. And we did testing with a soy-based cleaner, and it was very successful. I brought in 2 equipment suppliers who make ultrasonic systems, and they've given the company the quotes. So the company is evaluating them. Now, I'm just going to mention a couple other case studies in the Los Angeles area. One was a valve manufacturer. They refurbish valves, and they're made of all kinds of different substrates, which I list here on the slide. And they're largely contaminated with metalworking fluids from the field, but sometimes they have unusual materials on them, like the caked on bakery flour residue that I show here. And historically, the company used a 35-gallon open-top vapor degreaser for cleaning the parts prior to either a brazing or a coating operation. And we did testing, identified a water-based cleaner that worked, and we got equipment quotes, and the company converted to a spray cabinet. And here's a picture of the spray cabinet. And as you see, it has a turntable in the bottom where you place the parts. It has a spray bar that you can move up and down to get the parts cleaned. Now, spray cabinets of this kind can have a wash, rinse, and a dry. And in this case, we only are using a wash because the parts are heavily contaminated and it's a gross cleaning operation. So that's all we need. Now, here's the annualized cost comparison for the valve company. And again, I amortized the cost over a 10-year life for the system using a 3% discount rate. rate, excuse me. And I don't show an equipment capital cost for the vapor degreaser. The cost of the system in this case, that spray cabinet, was $8,000, and that translates into $900 a year. Once again, as you see, the cost of using the halogenated solvent is a lot higher than the cost of using the water-based cleaner. In this case, because it's a gross cleaning operation, we have to change out the water cleaning baths much more often, every month and a half. And so the cleaner cost is higher in the case of the vapor degreaser. The energy cost in this case is higher for the use of the water cleaning system. That's because the spray cabinet is partially automated. Now, as you see, we have decided that the labor costs did not increase with the use of the water cleaning system. It's the same. And once again, the disposal cost for the halogenated solvent is higher than the disposal cost for the spent water cleaner. And in this case, they're shipping it off-site for disposal. Now, as you see, once again, the total cost of using the system for the vapor degreaser is higher than the total cost for using the water cleaning system. And this company was able to reduce their costs by 18% by moving to the water cleaner. Now, this last case study manufactures nameplates, and 90% of their nameplates are made of aluminum, and the balance are made of stainless steel and brass. And they bring the nameplate stock into the facility, and they have a protective oil coating. They then processed them through a 50-gallon open-top degreaser, and they cleaned a huge volume of parts, about 1,000 of the nameplate stock per day. And we did testing. We found a water-based cleaner that was suitable, and they ended up converting to a conveyorized spray cleaning system. And here's a picture of that system. As you see on the front end, it has a conveyor. And on that conveyor belt, you place the nameplates. It goes through 3 chambers: a wash chamber where water-based cleaner is sprayed onto the parts at high pressure, about 120 PSI. It goes through a spray rinse and then through a dryer. And the rinse in this case is a recirculating rinse. And it goes out the other end on the conveyor belt, and the parts are clean and dry. And here's a slide that represents the annualized cost comparison for the nameplate manufacturer. Again, no equipment cost for the vapor degreaser. Now, in this case, the water cleaning system was quite expensive. It was $150,000, which included the recirculating rinse feature, which amounted to about $30,000. Now, once again, as you see, the cost of the cleaner in the case of the vapor degreasing system is higher than the cost of the water cleaner. In this case as well, because we're cleaning such a high volume of parts, we need to change out the bath every month and a half or so. Now, in this case, the energy cost of using the water cleaning system is much higher than the energy cost of using the vapor degreaser. That's because we've almost completely fully automated the cleaning process. And automation is very energy intensive. Now, in contrast, we've reduced the labor involved in the water cleaning process. Again, the automation helps us to do that. Now, once again, the disposal cost for the halogenated solvent is higher than the disposal cost for the water-based cleaner. In this case as well, they're shipping it off-site as water waste. Now, I show a row for deionized water. It's interesting, in the Los Angeles area, the quality of the water is very poor. And if you want spot-free parts, you need to rinse with deionized water. And this company does need to do that. And they bring in canisters of deionized water and change them out periodically. And that carries a cost of $3,000 a year. In the Pacific Northwest, the quality of the water is a lot better, I noticed when I moved here. And you don't have to use deionized water for rinsing. In that case, you just can use tap water. Now, once again, the total cost of using the vapor degreaser is a lot higher than the total cost of using the water cleaning system. In this case, the company reduced their cost of cleaning by 22% by moving to the water cleaner.
Dr.
Now,
Wolf,
you
you
will
have,
ask, is the cost of using the vapor degreaser always higher? And the answer is no. In some cases, the cost of using the water cleaning system will be higher. The tube manufacturer that I mentioned, they're going to have a higher cost for converting to the water cleaner, but mostly the costs for the water cleaning systems are lower.
Dr. Wolf, you have 5 minutes left in your presentation time.
Now, wanted to mention some issues that companies encounter when they try to convert to alternatives. Most companies start out wanting a drop-in alternative, and there isn't ever going to be one. And it takes a while for companies to understand that. And in fact, their vendors who supply them with the solvents will always be willing to sell them something that may be inappropriate for them to use. For example, right now, vendors are telling companies they can continue using their open-top vapor degreaser, and they can use 1,2-trans dichloroethylene. And as I already mentioned, that has a flash point, so that would be very dangerous to do that. I often find as well that companies, particularly those who have always used solvents, are very skeptical that water-based cleaners will work for them. And what I do in that case, in all cases actually, is I work with water cleaner supplier, and they are willing at no cost to test people's parts that are typically contaminated in their lab and find a water cleaner that's suitable for them. And usually you can tell by looking at the parts, I can at any rate, what kind of equipment will probably be required. And the water cleaner supplier has that kind of equipment in their lab. So once they do that testing and the parts get sent back to the companies for evaluation, the companies do believe that water cleaners may work because they're almost always successfully cleaned. And then I always bend over backward to make the alternative cleaning systems as low cost as possible. I mentioned the secondhand systems, and in addition, we did do testing of that spray cabinet with the fixture, which ended up being less costly than the ultrasonic cleaning system for the tube manufacturer. COVID-19 has been affecting business activity for certain facilities and not for others. The company that makes the optical components has had a decline in their business activity, and they're waiting to purchase the system as their business increases once again. So just to conclude then, water-based cleaning systems are really the most viable alternative, and they're the best alternative for almost all of the vapor degreasing operations that are done today. However, other safe alternatives can be used in certain cases. And I hope I've convinced everybody that there's not going to be a drop-in or a magic answer. You have to actually do the testing and find the alternative that's best for you. And the best strategy for companies is to find a permanent solution so they don't have to convert from one thing to another. That's all I have to say. And here's my contact information. I show my phone and my email, and please feel free to contact me and talk to me about any operation. I can also talk about virtually all other solvent applications and what alternatives might be suitable for you if you have questions. So I'd be very glad to answer questions now if people have them, if we have time.
Thank you, Dr. Wolf. And it looks like we do have one come in. The comment was, companies I work with generally want a 2-year payback. Do you have problems with offering economics as an annualization?
I'm sorry, could you say that last part again? They generally want a 2-year payback.
Yeah. And do you have problems with offering economics as an annualization? So I think they're wanting to know, like, what would be the payback on a new system?
Well, in these cases that I presented, it's over a 10-year life for the equipment. So Jen, all three of the companies that I presented the annualized cost information for saved money by going to the water-based cleaning system on that basis. But if companies want to pay back in 2 years, that's an awfully short time frame. And some of the companies probably got that. The microelectronics company probably got that because they're putting it through an existing system. I suspect that the company that's making the ducting will get that since they're going to use an existing system. They don't have to do an outlay of any capital cost at all. And the cost of using the water-based cleaner will be lower than the cost of using the vapor degreaser. But I think a 2-year payback is an awfully stringent requirement. I mean, and there are regulations that may be coming. I mean, people have to sort of get in gear to be prepared for that sort of thing.
Okay. The next question we had is, what about the physical space requirements for a vapor degreaser versus a water-based cleaning system?
Well, of course, it depends completely on the type of system that you end up buying. And floor space, you may need somewhat more floor space in the case of water cleaners. But for example, if you're a plating shop, for instance, and you're using a vapor degreaser and you convert to a water cleaning system, most platers, if they're removing polishing compounds, will have to use an ultrasonic cleaning system. And they will not have to rinse though, because they have a big plating line that has multiple rinses in it already. So you could even hope to get a smaller footprint in the case of a plating shop. So it very much just depends on what you're doing. And the spray cabinet that I showed the picture of takes up very little floor space, probably similar to what the vapor degreaser took up, or even less, perhaps. I hope that answered the question.
It certainly seems to. Do we have any further questions? Okay, seeing none. Certainly appreciate your presentation, Dr. Wolf, and spending time with us today. If anybody has any questions down the road, Dr. Wolf gave her contact information, so I invite you to contact her or whoever you might need to within your state. So thank you, Dr. Wolf.
Thank you.
All right, and we're